Welcome to the deep dive. We take the sources you give us, and, well, we dive deep, pulling out the most important bits.
That's the idea. Get right to the core of it.
And today, we're looking at something pretty fundamental from your material, the shape of the Earth. We've got arguments laid out for both sides, round and flat.
Yeah, it's presented as a direct debate in these sources. Point and counterpoint.
So our mission here is to basically unpack the main arguments, the evidence cited for each perspective. We want to give you a really clear overview of this whole discussion.
Regardless of where you're coming in from, knowledge-wise.
Exactly. Hopefully you'll have a few, aha moments along the way.
What's interesting right off the bat, the sources show this clash between, centuries of scientific observation and tech on one side.
The oblate spheroid side.
Right. And on the other, this emphasis on what you can see and feel yourself, questioning the models, questioning the institutions.
Okay, let's dig into that round Earth argument first then. The sources mention evidence going way, way back. Eratosthenes, measuring shadows in, 240 BCE?
Yeah, it's kind of amazing, using shadows and basic geometry to get a sense of a curve. But it's not just ancient history, obviously.
No, the text brings it right up to date. Satellites, GPS, stuff we use every day.
Exactly. And that's a key point made in the material. This isn't just theoretical. Your phone's location, weather reports, the internet backbone even.
Yeah.
It all depends on satellites doing their thing around a globe.
How so? Like the GPS specifically?
Well, GPS works by trilateration. It needs signals from multiple satellites, and their positions are calculated based on orbiting a sphere. That specific geometry. It just wouldn't give you an accurate fix on a flat plane. The math fundamentally relies on the curve.
Okay, that's a practical point. Makes sense. And the sources also talk about visual things, right? Like ships going over the horizon.
Yeah, a classic example. Hull down first, then the mast, like it's sinking over a curve.
And the ISS, you can literally see it fly over. It looks like it's orbiting something.
All consistent observations that, according to the text, point strongly towards a spherical model.
All right. So then the sources switch gears to the flat Earth view. And this seems to start from a very intuitive place.
It does. The ground looks flat where we stand. The horizon looks like a flat line. And crucially, we don't feel like we're spinning on a giant ball.
Yeah, that's a big one, isn't it? If we're moving so fast, why don't we feel it? And the text mentions seeing things far away, like city skylines.
Things that supposedly should be hidden by curvature if the Earth was round.
It feels like a reasonable question just based on what you experience day to day.
Absolutely.
Okay.
And this perspective, as laid out here, really champions that direct personal observation or abstract models. It asks why our senses seem to contradict the scientific story.
And there's skepticism too, right? Towards NASA imagery, claims of composites.
Questioning the visuals we get from space agencies. And suggesting maybe financial incentives are driving the whole space narrative.
The text even offers alternative explanations, like satellites are just balloons, GPS uses ground towers.
Yeah, those are points raised. Trying to explain the tech without needing a globe.
And for astronomy, like stars moving in circles.
Explained in the flat Earth view here as a celestial dome rotating above us. And lunar eclipses. Not Earth's shadow, but maybe some other shadow object up there.
An anti-moon, the text calls it. Interesting.
It is. And then there's the plane argument.
Ah, yes. If the Earth is curved, why don't planes constantly have to dip their nose down? They seem to fly level.
It sounds logical on the surface. A very common point raised.
Okay, so how does the round Earth side in the source material respond to these points? Let's start with the not feeling the motion.
Well, the explanation given is uniform motion. Like being in a smoothly moving train or plane. You don't feel the speed itself, only changes in speed or direction. Earth's rotation is incredibly constant.
Makes sense. And the curvature we don't see.
The text explains it's just too gradual over everyday distances. About 8 inches per mile, but it's squared, so it adds up. You need instruments or very long distances, like with long-distance photography or laser gyroscopes, to really measure it effectively.
And the plane's flying level.
That goes back to gravity. Level, for a pilot, means flying perpendicular to the pull of gravity, which points towards the Earth's center. So, as the plane flies, level naturally follows the Earth's curve. The plane isn't fighting the curve. Gravity guides it along it.
Okay, so level isn't a flat line in space. It's relative to the Earth below.
Precisely. And going back to GPS, the system, as described, absolutely needs satellites orbiting a sphere. The timing, the angles, the math. It all falls apart on a flat model.
And rockets. Satellite orbits.
Again, explained by gravity pulling towards the center of a massive sphere. Their trajectories are predictable based on that model, and the text stresses Space travel isn't just one agency, it's multiple countries, private companies.
Verifiable by independent groups.
Exactly. A conspiracy of that scale involving so many scientists, engineers, even amateur astronomers tracking satellites. The text argues it's just incredibly implausible.
What about lunar eclipses then? The shadow object idea.
The counter-argument is simple. The shadow seen on the moon during an eclipse is always curved, consistently round, which is what you'd expect from a spherical body casting the shadow.
And the text mentions Galileo. Flat earthers sometimes bring him up as someone who questioned authority.
Right, but the key difference pointed out is that Galileo questioned authority with evidence, his telescopic observations, mathematical reasoning. He wasn't just rejecting data, he was providing new data.
The text also lists other evidence for a round Earth, doesn't it?
It does. Things like the Coriolis effect, which affects weather patterns and long-range ballistics.
Like artillery needing corrections for Earth's rotation.
Exactly. And fiber optic gyroscopes detecting rotation. Even shipping companies using spherical Earth models for navigation.
So a lot of accumulated evidence from different fields.
Now, the flat Earth arguments, as presented, do push back on some of this.
Like the Coriolis effect.
Yeah, arguing it's not something you directly see or feel in everyday actions, so maybe it's misinterpreted or not real. And there's a sense that their alternative explanations are dismissed too quickly.
Like the idea of a local sun moving over a flat plane. Could that explain daylight and time zones?
They propose models like that, yeah, trying to make a flat map work with observed phenomena. There's also skepticism about flight paths, especially over Antarctica, suggesting maybe GPS is faked or pilots are misled.
So distrust is a major theme there.
Definitely a distrust of the established models and the data supporting them.
But the text seems to draw a line between the two approaches based on prediction, right?
Yes, this is highlighted as a crucial difference. The round Earth model allows for predictions, predicting eclipses centuries in advance, predicting satellite paths, predicting gravitational effects.
It's predictive.
Exactly.
Right.
Whereas the flat Earth model, as characterized in the sources, tends to be more reactive. An observation is made, like a lunar eclipse, and then an explanation, like the shadow object, is created to fit it. It's often retrofitting rather than predicting.
That feels like a really important distinction in how science generally works.
It is. It touches on the core of the scientific method. Hypothesis, prediction, testing, falsification. The round Earth model has gone through that process countless times. The text contrasts this with flat Earth arguments, often rejecting established physical laws or data that contradicts the flat model.
It also addresses that idea of questioning authority.
Yeah, acknowledging that questioning is healthy, but emphasizing needs to be evidence-based skepticism, not just rejecting things because they come from an official source, but examining the underlying data and reasoning.
And the text ends up posing that question directly, doesn't it? If you doubt the Earth is round.
What evidence would convince you otherwise?
It makes you think, especially when compared to the flat Earth view's reliance on sort of common sense, direct sight, and that inherent skepticism.
Ultimately, the conclusion drawn in the material is pretty clear. The shape is determined by physics, geometry, astronomy, measurable, testable data, not belief or politics.
So, quite the journey through these arguments. We've seen the oblate spheroid case, built on everything from ancient observations to GPS tech that shapes our lives.
And then the flat Earth perspective, really grounded in that immediate sensory experience and a questioning of the standard narrative.
And finally, the rebuttals, the extra evidence, and this key difference in predictive power versus, explaining things after they happen.
It really highlights two fundamentally different ways of approaching knowledge as presented here. One builds on this vast, interconnected framework of evidence and prediction.
And the other starts from personal experience and questions anything that seems to contradict it.
Exactly.
So for you listening, it really leaves you with some things to chew on. What counts as convincing evidence for you? How do we use models to grasp things we can't easily see or feel directly?
And how do we navigate claims, especially ones that challenge widely accepted ideas? It's about critical thinking, really.
Maybe you could look into the history yourself, see how understanding evolved, or dig into some of the science we touched on. How does GPS actually work, or what is the Coriolis effect in detail?
Yeah, engaging with the details, weighing the evidence from different angles. That's how you build your own informed picture of the world.